Hello, and welcome to the third video in this series of EG168 Matlab videos. This video provides an introduction to using M files and plotting with Matlab. Matlab M files are designed mainly for larger projects and performing calculations one at a time, as we have been doing up to now. So, to create an M file, you can click on New, and then Script. Or if you haven't got a script open already, you can also click New Script. However, we have got a script open, so let's start with this one. Now when saving your script, you must make sure that it starts with a letter and should not contain any spaces, or else Matlab will struggle to run it. You should also enable that it is easily accessible, so if I were to save this now, I would make sure that it is in an area I will be able to find easily later on. And once I save it, it will be able to appear over in the current folder location, so even when I close it, I can easily reopen it. So let's call this calc. And stress. And that will then save as an M file to a location of my choosing. So let's start with summarizing the display function. If we were to type in the following, so display summarizes disp and stress. So put that in apostrophes, stress. And then if we are to run that, however, if I run that now, we probably won't get anything, since this little star up in the corner indicates that this file is not yet saved. So if you can see a star next to the name, make sure you click Save. And when it disappears, you're ready to run. And as you can see, it then displays the word stress as we asked. So, after we have done that, we can also think of the other ways in which to run your M file. So as well as doing that, we can also click F5, or we can drag across your folder name from the current folder location and into the command window, where it will run automatically. However, this is quite simple and not far off what we've done up to now. So the best thing to think of in this example is algorithms. When creating a more complex code with equations working together, some information requires calculating before moving on. Therefore, a sequence of steps which are needed for the task to be completed must be formulated. This is known as an algorithm. So let's make a basic algorithm based on this handout, looking at the stress calculation. So this is similar to the handout, I must add, but not precisely what you have, just to make it a little different. In this case, we will be calculating stress, which is equal to force per unit area, where stress in pascals is the first unknown, the force in newtons is the second unknown, and the area in meters is the third unknown. Therefore, an algorithm can be organized to first get the values in force and area. Second, use the equation stress equates to force per unit area, and then finally find the output for the stress when the program is run. In order to do this, we can type out the following. So we want force to equate to the input value of whatever we want our user to enter. So we'll make this a user interactive algorithm. So instead of just typing out a value, I can prompt my user, whoever wants to use this code, to input their own values. So let's give them a bit of instruction. So apostrophe, then we want them to enter the value of force, and we'll have that in newtons. end with an apostrophe. That enables the script to be read. And then let's ask for area. We'll make this also user input. So area equates to the input, whatever the user defines following this statement. So we want them to enter the value of area, and we'll have that in meters. And then stress will be equal to this force per unit area. And then we want it finally to display stress. This time, not just the word stress, but the stress actually calculated. Now, this should be fine to run. However, if we were to come back to this file after a while, we may find it a little easier to understand with annotation. Also, it is good to get into the practice of annotating your work, since it will make it far clearer to you once you have come back to it after a time. So, at the top, we can add in the following. So, when we're adding annotation, we should make sure to use the percentage sign, because this will tell Matlab this isn't code to run, this is just for our own personal use. So we want to remind ourselves to program to calculate stress. So we know that this is a program to calculate stress. And make sure that you always remember this percentage sign, because if you don't, it probably won't run. Then, just above input, you can type in step 1, get values for force and area. And then after that, step 2, use for force, stress equates to force per unit area equation to calculate stress. Then finally, above the display command, you want to write in step 3, and output the stress. Now, once you have saved it, you are ready to run the file. So let's try running that. Okay. And the first thing it wants us to do, as I have prompted, is to enter the value of force. So say 10 newtons. And now we want the value of area in meters, so let's call that 5. And then stress comes out as 2. Which is exactly what we want. It's force per unit area. However, that's quite a simple process, so let's move on now to looking at matrix algorithm and matrix algebra. So to start with, let's refresh our minds on some of the terminology. So a scalar is a single value and a matrix with only one row and one column. A vector is then a list of numbers, so a matrix consisting of either one column or one row. Then finally, a matrix is any grid of numbers normally containing multiple rows and columns. However, this term can be used to refer to vectors and scalars. So to start with, we can look at the addition and subtraction of matrices. For example, if we wanted a scalar value to be added to our matrix, we could do the following. So let's start by creating a new M file. And just save this one again. So new script, and we can call this one vessels. So once again, save to a location you'll remember, and I'll always start with a letter. Here we can define a matrix called mass VG. Make sure that you use correct terms as well. You'll regret it, and once you have defined it, I would advise either copying and pasting it across, or make sure you use all of the correct terms, so make sure the cases are correct and everything else. And we can equate that to 23, 34, 20, then make a new row, and then we can have 42, 16, and 19. And then if we want to remind ourselves of why we've done this later, once again it's probably best to annotate it. So let's add some annotation, and we can tell ourselves to define the masses of the empty vessels. So we are once again creating a little prompt for ourselves. Then, if we wanted to add 10 grams of fluid to each of the vessels, we can type in the following, and sticking with the annotation. So, add 10 grams of fluid to each vessel, and we can define that as mass VF in grams equates to mass V grams plus 10. So if we save that, we can then run this, and this will give us the new mass of each vessel as well as the mass of the fluid added to it. So let's run that. And there we have it. On the other hand, if we want to add or subtract matrices from one another, we need to ensure that they have the same number of rows and columns. So continuing with matrices of masses, we can make a new M file, and this time looking at the masses of 6 vessels, with the initial matrix defining them when they are partially filled, and the second one defining the amount of fluid to be either added or removed from the vessels. So if we type the following, making sure to use annotation to help us with the understanding later on, we can do this. And let's just stay in the same file. Define fluid mass to be added or subtracted from vessels. And that could be mass of fluid in grams, equates to, let's go 2, 4, 5, 0, and 2, 2, 1. Then if we want to add masses, we can type out mass VF1 in grams equates to mass VF G grams plus mass F in grams. And then for subtracting masses, we want that to be equal to mass VF1 in grams, and let's be a little lazy. So we want that equate to the same except minus mass of the fluid in grams. Now, if we save these, we can then run this M file. And you will see that for two matrices, add and subtract from one another, since they are both the same size as 2x3 matrices. However, if you were to try adding or subtracting matrices of different sizes, say a 2x3 matrix with a 3x2 matrix, so let's try that. And we'll create a new M file for that. So new script, and save it as masses A and B. And we can't have spaces, so get rid of all the spaces. Can't use that either, so let's call it A and B. So always remember, start with a letter and no spaces. Only use letters, numbers which you're able to use. And there we have it. And let's create a mass A and equate that to 1, 2, 3, 0, 4, 5, 6. Always. No idea why it's doing that. Also, if your computer decides to have a hissy fit, just be patient with it. And then mass B. Equate that to 1, 2, 0, 3 and 4, 0, 5 and 6. And then we should find, if we try adding together, so mass A plus B and if we make that equal to mass A plus mass B, if we save and run that, that probably shouldn't work, and there we have it. Because they're not the same type, it is not possible. And we will find the exact same issue with subtraction. So let's try that again. And that doesn't work either. However, multiplication on the other hand is quite different. although multiplying a scalar quantity is the same as with adding or subtracting, when multiplying matrices or vectors, you will find that they don't work quite the same. So if we were to try multiplying, let's go for masses of the F and F, and let's make it so that's the only one that runs, so we don't have to see everything again. Remember, semicolons mean don't have to see. If we copy that out and multiply it instead, we should find, because they are both the same type, with both matrices being in the same orientation of 2 by 3, should find they don't work. So let's try multiplying those together, and we use star for multiplication. And if we save that and run it, as I mentioned, it's not possible. In order to multiply these matrices, you will need the number of rows in matrix 1 to be the same as the number of columns in matrix 2, and the number of columns in matrix 1 to be the same as the number of rows in matrix 2. So in this case, matrix 1 will need to be a 2 by 3, and matrix 2 will need to be a 3 by 2, or vice versa. Therefore, if we wanted to multiply these two together, we would need to transpose one of them. So let's try the following. Let's make mass F transpose, which we do by adding an apostrophe, and this will change the orientation around. And if we save that and try that again, as you can see, it does work. Now, since masses A and B from earlier had the same number of rows in mass A as the columns in mass B, and the same number of columns in mass A as the number of rows in mass B, making one a 3 by 2 matrix and the other a 2 by 3 matrix, this should work. So if we had to type this out instead, so let's put a hold on that and type out mass AB equates to, we'll copy this over to save time, and we want those to multiply. We should find, if we save it, this will work. And it's still a bit hung up on that, so let's get rid of this one so it hasn't got any errors at all. Save that and run that instead. And there we have it, mass AB. Perfect. So, in the same principle, we can apply this to vectors. So if we wanted to multiply vectors together, you wouldn't be able to multiply a row by a row. You would have to multiply a column by a row by a column. Or if we were to multiply 2 rows, we would have to transpose one of them to become a column, and vice versa. Okay, but moving on, I think that's enough with the matrices.